Alright, let's look at this problem called buddy strings. What is given to us? Given two strings s and goal, return true if you can swap two letters in s so that the result is equal to goal, otherwise return false. Swapping letters is defined as taking two indices I and j. Yeah, we know what swap means. For example, swapping an indices 0 and 2 in ABCD results in, so C and A get swapped here. So we have to basically, so two strings are buddy strings if there is exactly two, if you can swap any two letters within a string and it becomes this other string, right? If you can swap two letters in s, so the result is equal to goal. Okay, so that's what we are looking at. So for example, AB BA, you swap B and A, so the answer is true here. AB and AB, well, you can't do any swaps here. AA and AA, this is an interesting case. I mean, uh, it's just quite interesting because you can, there are duplicates here, so there are swaps. So for example, if you look at two strings that are equal, so these two strings are equal, here the answer is no, here the strings are equal but the answer is true. The reason is here there were duplicates present, and because there are duplicates present you could swap those duplicates. So that's a special case. And let's look at simple example of this one. So you have A B C D and C B A D. So what happens is there has to be exactly two mismatches between the two strings, right? So if you look at these, for example, A and C mismatch, C and A mismatch, and the first mismatch is opposite of the second mismatch. So exactly two mismatches, and what else do you want? So yeah, there is exactly two mismatches, and first mismatch is opposite of, exactly opposite. What I mean by mismatch, so basically I'm comparing these two strings. I compare each and every letter. So B and B match, D and D match, A and C did not match. That was the first mismatch. A and C did not match, so I keep track of A and C. Then C and A did not match, so I keep track of C and A, and then I compare, hey, it was AC and this time it was CA. It's completely opposite of the second mismatch. That's one case. uh, that is one case where you can do. Other cases, exactly zero mismatches, right? The strings are equal. So this there also strings are equal, there also strings are equal. However, you need one more thing, at least one duplicate character, so you can swap its positions. So basically AB was not true because you have to at least do one swap. So if you do one swap it becomes BA, but here if you do one swap AA, so those are the two conditions that you have to keep track of. Now how do you find out if there is a duplicate? So it says S and goal consists of lowercase 26 characters, so we can check the presence of each character from A to Z in the string, and if it's occurs again then it will be a duplicate. So let's first solve for this case, right? And then we'll add this additional condition. So how do I do this? So uh, so we want to keep track of the mismatching characters. So let's say C1, initialize it to something, doesn't matter initially. Okay, so before that also, the strings have to be equal in length, right? So if s dot length is not equals to goal dot length, then right away you have to return false. Now you go through each and every character. So for I equals to 0, s less than dot length plus plus, grab the characters of the indexes. So x equals to s dot caret I, and let's say y equals to s dot caret y. Now if they don't match, if x is not equals to y, then what you're gonna do? Let's keep track of mismatches. Initially there are no mismatches, right? So if this is the first mismatch, if this is the first mismatch, then you save these. So you save these, that's all. What else? If it's a second mismatch, then if c1 is no, so it has to be exactly opposite. That means x and c, xy, c1, c2 should match in the opposite order. So if x is not equals to c2 or y is not equals to c1, then again there is a problem. We just return false. Else you have to say mismatch resolved, right? So you can say here, if they are exactly equal, then mismatch is resolved equals to true. And if there is something else, that means there are more than two mismatches, just return false. And you do mismatches plus plus. Yeah, that's the idea. So what would you return? So basically I want the mismatch count should be 2, right, because this is plus plus. So and the two mismatches cancel each other. I mean if the mismatch count is 2, then they would have cancelled each other, right? Because because otherwise the mismatch count would just be 1. Yeah, so I don't think we explicitly need this, and if we need, we'll add it again. But basically if the mismatch count is 2 and they're not resolved, then you would have anyways returned false here. So but there is another condition, which is this one, if there are no mismatches. So or but in that case you need something, at least one duplicate. So you just say has duplicate. And now let's calculate. So let's say boolean has duplicate equals to false to begin with. You need to check the presence of each and every character. So let's say because there are only 26 characters, you go do that. And here let's say if not present x minus a, if it is not present, then you mark it present. And if it is already present, then it's duplicate. So you just say, so if the strings are exactly equal, then the mismatches will be 0, and in this case if it has duplicate, then that's the thing. Okay, let's run, fix the compilation errors. Okay, first one is wrong. ABBA, well, there have to be two mismatches and they should cancel each other. So mismatches equals to 2 should have solved it. Let's see what happened. So you go through each and every character. Okay, it's not S, it has to be goal. Okay, let's run again. Okay, all the three test cases passed. Let's submit. Okay, seems to work. Let's quickly talk about the time and space complexity. So what are we doing here? We're using some space for this finding duplicate uses presence, but this is almost of over 26. We can almost call it constant. So space complexity over 26, or like over 1, you can say it. Time complexity, you're going through the length of the string. So O of n, which and n is the length of the equal strings. I mean equal length strings, because they have to be equal length. So it's O of n, O of 1. All right.